4.7, graphing system of linear inequalities. So we did this kind of problem before, but in the past it's only one inequality. And now we have to graph a system of it. So we're gonna have to do the same thing twice. So as you can see, system of linear inequality have two inequalities in each system, and we want to know what is the solution of it. So the solution will be very similar to system of equation, which is an order pair that satisfy to both of the inequality. So as usual, the very first example will be determining a given order pair is the solution of the system of inequality or not. So we're going to have to substitute into the inequality and test it. So the first one is x minus 5y is greater than 10. So when I substitute 2 for x and negative 2 for y and testing it. So this gives us 2 plus 10 is greater than 10, which is 12 is greater than 10. So it's satisfied for the first inequality. So now I need to continue testing. Does it on the second or not? So 3x plus 2y is greater than or equal to negative 2. So 3 times 2 plus 2 times negative 2 is greater than or equal to negative 2. So that gives us 6 minus 4 is greater than or equal to negative 2, which is 2 is greater than negative 2. So this is also true. Because of it satisfies both inequality, now I can say that therefore 2 negative 2 is a solution. A system of linear inequality have many solutions, so we need to know how to find those out. So we're going to represent by graphing methods, right? Graphically. So you need to remember greater than or less than, those symbols are dashed line, less than or equal to, or greater than or equal to are solid lines. Okay. As usual, we're going to first draw the boundary line and then test a point that is not on a boundary line to see which side is the solution. And we're going to have to do it twice because we have a system, two inequalities. So let's take a look at on example number 1. So to graph the boundary line for the first inequality, so let's say x minus 5y is greater than 10. And first we want to draw the boundary line. And this boundary line is dashed it because the inequality symbol is what? Less than. So solving for y, which is put into slope-intercept form, and divide both sides by negative, so the inequality symbol will be switching around when you divide it by negative 5 to both of them, right, on the right hand side. So this gives me y is less than 1 over 5 x minus 2. And this allows us to graph, which is my y-intercept is -2, and then the slope is 1/5. So go into the graph. My y-intercept is -2, which is right here, and then the slope is 1/5. So go up 1 and to the right 5 units, which is right here, and go up 1 to the right 5 unit, which is another point right there. And we know that it is a dasher line, right? So we're gonna draw dasher line. Now the next step is testing a point to find out which side is the solution. And you already saw that 0, 0 is a possible number to test. So we would test 0, 0 and plug it into the original inequality. 0 minus 5 times 0 is greater than 10. And we can see that 0 is greater than 10. That is false. So that means if this side is false, then the other side must be true. The other side must be true. But however, I don't want you to uh, shade very large, right? Shade the whole things at the bottom, because that's not our final answer yet. So this is how I want you to shade it. After we found out, we're gonna shade just very close to the line, the boundary line, just to indicate that our solution for this inequality is below the line. Okay. Now you're gonna do the same process again for the second inequality. So second inequality, that is 3x plus 2y, that is greater than or equal to -2. First, we're gonna look at the boundary line. Right? The boundary line in this case is solid because the inequality symbol is less than or equal to. So solving for y, I subtract 3x on both sides and then divide by 2 to both sides. So minus 3 over 2x and divide by 2. So that'll give me y is greater than or equal to -3 over 2x minus 1. Now we know that our y-intercept and the slope, so I can graph this. My y-intercept is -1 right here. The slope is -3 over 2, so it will be go down 3 units. 1, 2, 3 unit, and to the right 2 units, which is right here. And continue, go down 3 unit, and to the right 2 units, which is another point right here. Now we know that this is a solid line, so I'm gonna draw a solid line. Okay. Now after that, we're gonna have to test the point, right? As usual. I need to draw my line better because let me put another point. So go up 3 units and then to the right 2 units, which is here's another point. So my boundary line will be going like this. So clearly we can still test 0, 0, right? Testing 0, 0 into the second inequality, which is 3 times 0 plus 2 times 0 is greater than or equal to -2. 0 is greater than or equal to -2. That is what? True. So that means this side is true and this side is false for the blue line. So I'm going to shade it on the true side. Right? I'm going to shade it on the true side, which is this portion only. Since this is system of inequality, the solution that we are looking for is the shaded region that is overlapping, meaning everything in here will be our solution. So that's the reason why I asked you to graph, to shade it like just close to the line so that your final answer can be clearly seen. Okay, let's move on to the next example. Example 2. So let's take a look at on the first inequality. 3x minus 2y is greater than 12. Boundary line is, in this case, will be dashed line because of this inequality is greater than. So subtracting 3x on both sides, and then divide both sides by negative 2, those that inequality symbol switch it around. So negative 3x divided by negative 2 plus 12 divided by negative 2. That gave us y is less than 3 over 2x minus 6. So this helps us to graph it, right? So graphing the first inequality. So my y-intercept is negative 6, my slope is 3 over 2. So here's negative 6, that's my y-intercept. The slope is 3 over 2, so go up 3 units, and to the right 2 units. Go up 3 units, and to the right 2 units. And we know that this is a dashed line, so I'm gonna draw a dashed line. And dash the line. Now we're gonna do the testing. And from the graph, we saw that 0, 0 is okay to use, right? Because it's not on the boundary line. So it'll be 3 times 0 minus 2 times 0 is greater than 12. 0 is greater than 12. That is false. So therefore, we know that this side is false and this side is true. And we're going to shade it on the side that is true. So that will be below. So like before, we're going to draw only close to the boundary line so that we can get our final answer. So now we're going to do the same thing for the second inequality. So the second inequality is y is greater than 3 over 2x plus 1. It's already in slope-intercept form. So this tells us our boundary line, right? Our boundary line is also what? Dashed line. So the slope is y-intercept is 1. The slope is the same, 3 over 2. We know that this is going to be a parallel line. So here's y-intercept 1. The slope is 3 over 2, so go up 3 units, and then to the right 2 units. Go up 3 units, and then to the right 2 units. And again, this is a dashed line. And we know that it is going to be a parallel line. Now, what we're going to do is we're going to test the point, and also clearly 0, 0 is possible to test. So we test 0, 0. So which will be 0 is greater than 3 over 2 times 0 plus 1. So 0 is greater than 1, that is false. So that tells us this side is false and this side must be, oh wait, my bad, the other way around, right? I wrote it wrong place. So this side is false and this side must be true. So we shade it on the true side, that is right here. So from this graph, you can clearly see that there is no region, the shaded region that is overlapping. So that basically means no solution for this system. Okay, no solution for this system. So finally, the last example that we want to look at it. So the last example, this times I'm gonna yeah. So the first equation, inequality is y is greater than 3x plus 1, and we know that our boundary lines, that we what dashed it because of here. And then testing, we're gonna have to graph it first, right? So when I graph this, this will be my y-intercept is 1. My slope is 3, so that means 3 over 1. So go up 3 units and to the right 1 unit. Go up 3 units and to the right 1 unit. And then it is a dashed line. And testing the point, and let's do the testing of like 1 0 clearly on this side. So my y is 0, my x is 1, so that would be 0 is greater than 4. This is false. So that means this side is false and this side is true. So we shade it on the true side. Now continue to the same process for the next inequality, right? But the second inequality is already given it's given to you in 3x plus y is greater than or equal to negative 4. So by just adding 3x to both sides, that gave us two graph. So my boundary lines, in this case, is solid. Okay. Now you don't need to write it down like solid and then dash it on a test. I'm just, this is for the notes purpose. I'm writing, keep on writing over and over again so that you can see it. Okay. And now I'm gonna graph this, which is my y-intercept is negative 4, which is right here. And the slope again is 3, so it'll be go up 3 units and then to the right 1 unit, 1, 2, 3, and then to the right 1 units. Go up 3 units, 1, 2, 3, and to the right 1 units again. So this time it is a solid line, so I'm going to be drawing a solid line right there. So notice that again, these two lines are parallel because they have the same slope. Now I have to test it, okay? And test 0, 0. So I will substitute into negative 3 times 0 plus 0 is greater than or equal to negative 4. 0 is greater than or equal to negative 4. That is true. So that means this side is true and this side is false. So I will be shading on this side, everything on this side. So basically what happened is the region that overlap will be everything on the right hand side, on the left hand side of the red graph. So this will be the solutions for us in this case. Okay, and that will conclude this sections